So, all the students already taken the theoretical explanation of Thevenin's theorem. So, this class we are concentrating how to solve the complicated problems on Thevenin's theorem. Right. So, as we know, in any linear bilateral network consisting of number of voltage sources or number of current sources or combination of both voltage and current source can be replaced by single voltage source with series resistor, which is the Thevenin's equivalent circuit. So what is the disadvantage of this mesh and nodal? Let us imagine we are having a circuit containing 50 meshes. We have to generate 50 mesh currents. So that circuit, that procedure becomes complicated in fact in practical approach. So what this Thevenin has mentioned, any complex circuit can be converted into a single circuit which contains a single voltage source with series resistor. Now we got the bridge type of problems where the question is calculate the current flowing through 5 ohm resistor using Thevenin's theorem. So according to Thevenin's theorem, so same problem can also be done by the mesh analysis 1, 2 and 3. But if in the examination they mention Thevenin's theorem, we must use the Thevenin's theorem technique. So whatever may be the circuit, they will give the indication A or B or any current value. So the step 1 in Thevenin's theorem is remove the load resistor present between the terminals A and B. So diagram each step, the new circuit formation we are supposed to represent. If you see, we have removed the load resistor, which is 5 ohms, which is present between A and B. Redraw the circuit. Now, step 2 is all about calculation of Thevenin's voltage, which is VTH. So, in order to calculate the Thevenin's voltage, let us redraw the circuit in a convenient manner. The same circuit, here we got the open circuit terminals A and B. Remember, open circuit means we are having the voltage at this terminal. The same circuit we have redrawn. Now, if you see this circuit, the circuit same 100 volts is applied in parallel to 10 and 6 combination and 15 and 8. So we can divide this circuit into two different parts. So let us say this is the first part one, where 100 volts is giving energy to 10 and 6. So what is this Thevenin's voltage? How to calculate? So before we do that, Thevenin's voltage VTH is nothing but the voltage present between the terminals A and B, VAB. So VA minus VB, VAB equal to, as we know, the potential voltage is nothing but the potential difference between two end points. So if I want to calculate the voltage between A and B, we should calculate VA and we should also calculate the VB and take the difference of these two voltages, which gives the Thevenin's voltage. So let us divide the circuit and calculate the voltage across the terminal A. So here if you see, the terminal A is connected to 10 ohm resistor and 6 ohm resistor. So voltage across A terminal can be taken as V10, voltage across 10, or voltage across 6 ohm resistor. So if you are going for the upper part calculation, in both the circuits you have to take the upper part only. That means if I am selecting VA as 10, you have to go for VB as 15. You are selecting VA as 6 means then you have to go for the VA as 8. Okay, so we cannot take this VA as 10 and VB as 8, upper part or lower part. That means whether if you are taking VA as 6, you must take the VB as 8. So what is voltage across terminal A? It is a voltage across 10 or voltage across 6. So let us take the combination 10 and 15. Whatever the combination you take, you will get the same answer. So let us, I'm just taking voltage across terminal A is nothing but voltage across 10 ohms, 10 volts. Okay, voltage across 10 ohms. So what is the voltage formula we know? Voltage across 10 ohm resistor equal to 10 into I. V is equal to I into R. Okay, so I into 10. So if you see, apply the loop current. So 100 equal to I into 10 plus 6. I into 10 plus 6. And I is equal to 100 by 16, which comes to 6.25 amperes. But we require the voltage across 10 ohm resistor. So I into 10, which is 62.5. We say V voltage across 10 and voltage across the terminal A is equal to 62.5. Let us see the next case in the circuit. Next part. So let me maximize this. So if you see the second part of the circuit, So 100 volts is again applied to the 15 and 8. Now what is the voltage across the terminal B? It is a voltage across 15 or voltage across 8. As we have taken the initial case as voltage across 10, we have to take the volt B is nothing but voltage across 15 ohms resistor. So we know the formula for the voltage V15 is equal to I into R, 15 into I. So apply the KVL, 100 is equal to I into 15 plus 8. So I is equal to 100 by 23, which is 4.34 amperes. Just to multiply, as we know, voltage into current, I into R is the voltage, 15 into 4.34, which gives the value 65.217. So what is VAB? V voltage across terminals A and B is nothing but open circuit voltage or the Thevenin's voltage VA minus VB. So VA is 62.5, which we have achieved. Right now VB is nothing but 65.21. So we do get VAB is equal to minus 2.71. We are supposed to take the potential as it is the Thevenin's voltage, 2.71 is the voltage. So next step, after calculation of VTH, you have to go for the determination of the RTH, Thevenin's resistance. We all know that Thevenin's resistance is the equivalent resistance seen from the terminals A and B when all the voltage sources are short circuited and current sources are open circuited. That means in this problem, we are not having current source, only the voltage source is short circuited, that it is replaced by the copper wire, the same circuit. Now, in order to know whether the resistors are connected in series or parallel, let us redraw the circuit taking the terminals. So I'm starting the circuit, redrawing the circuit, starting from the terminal A. So if you see A, so A is connected to 10 and 6, the same direction. A is connected to 10 and 6 or 6 and 10. And both the junctions 10 and 6 are connected to each other. And the 6 is, okay, here also you can see 10 and 6 are connected to each other. And that combination is connected to 8 and 15, you can see. So here we say 8 and 15 are again connected to the point B. Okay, B is connected to 15 and 8. So final combination is 10 and 6, both are connected to the 10 and 15, the same diagram we have drawn. Now it becomes easy to mention this whether they are connected in series or parallel. Assume the current is flowing. Now 10 into both are connected in parallel. This is also parallel combination. Overall combination is connected in series. So 10 into 6 by 10 plus 6 plus 8 into 15 by 8 plus 15, which gives the RTH. What is the step 4 after calculation of RTH and VTH? So here comes the step 4. Represent Thevenin's equivalent circuit. The Thevenin's equivalent circuit is voltage source with series resistor, Thevenin's voltage with RTH resistance. And stepwise, reconnect the load resistor to the Thevenin's equivalent circuit. In the step 1, we have removed the load resistor. Now we are reconnecting it. The load resistor 5 ohms is reconnected to the Thevenin's equivalent circuit between the terminals A and B. Now just applying the KVL, we do obtain the current. I is equal to VTH by RTH plus RL. This is the solution. So in this way, we calculate the current flowing through the resistor using the Thevenin's theorem.